speaker, Pim Elshoff, is English-spoken speaker. So he's a Scrum developer at Procurious, and his extensive experience with solid coding and patient mentoring and tackling big projects using domain-driven design skills are very interesting for, as a background for today's talk, Final Class Aggregate. So let's give a virtual online applause to Pim.
Hey, Pim.
Hello, can you hear us?
I can hear you. Can you hear me?
Yeah, great.
Perfect. So hi, my name is...
Have a good talk.
Good. Hi, my name is Pim. I have some allergies, so I hope they will be a bit contained today. I'm going to be talking to you about Final Class Aggregate. There are three kinds of people that see this image. Some people will say, what function exactly often is the aggregate? If you're one of those people, then get out, just shut the stream off. I don't even want you here. Now, if you're somewhat of a normal person, then you'll say, what exactly is the function of an aggregate? Now, if you're somewhat like me, then you'll say, what exactly is the function of an aggregate? It's a reference to the Harry Potter movie. I really enjoyed those when I was younger. This scene, for some reason, stuck with me. Mr. Weasley asking Harry Potter, tell me, Harry, what exactly is the function of a rubber duck? Now, Harry Potter is all about magic, but of course to us programmers, rubber ducks are not exactly magic. We know exactly what the function of a rubber duck is. You talk to it, obviously. But aggregates, I've been doing domain-driven design talks, workshops for a couple of years now, and always that same question. Tell me, Pim, what exactly is an aggregate? So today, finally, once and for all, the final non-extendable definition of aggregate. Are you ready? So, an aggregate is a pattern of encapsulation that prevents a legal application state by hiding information behind strict rules and behavior or transactional consistency behind a transactional boundary. In other words, we'll spend a little bit more time on it, don't worry. Aggregates, just like value objects, entities, and other DDD tactical patterns, are a pattern that help us to make the incorrect inexpressible. If you happen to catch my previous talk, then you'll be still hearing that somewhere in the back of your head, make the incorrect inexpressible. Yes, that is what the DDD tactical patterns help us to do. Aggregates are nothing special in that regard. So these patterns, they are common solutions, common kinds of solutions to common kinds of problems. And they all have to do with identity, state, rules, and behavior. Putting aggregate in the title of this presentation is a little bit of clickbait. We will be discussing aggregates, but more today will be about rules and behavior at the information. Rules and behavior at the information. So when we talk about rules, what we mean is state transitions that we explicitly disallow, that we don't want our software to support. When we talk about behavior, we mean state transitions that we explicitly do allow and support. When we talk about information, we mean identity, state, data, anything our software needs to make those decisions. And today, we're going to be talking about rules and behavior at the information. In other words, that the need for information, not information itself, but the need for information is what drives design. We're going to be talking about this in 3 stages. First, we'll talk about objects and messages. After that part, you will know what an aggregate is. Then we're going to discuss what context is and why it affects the way we look at aggregates. After that section, you will know when to use aggregates. And then we are going to look at some heuristics. It will be a short session, just a couple of guidelines that you can memorize or not. And after that section, you will know how to use aggregates. Objects and messages, context, and then heuristics. So let's look at some object and messages first. You really can't do a presentation on object orientation without at least referencing LNK. But I'm not going to do that today. All we are interested in today is that objects are little problem-solving machines. Programming is the art of problem decomposition and solution composition. So when we are faced with a big problem, we split that problem up into tiny little problems, solve all those little problems, and then compose them back into a solution. And we solve those little problems by creating objects that will take care of those problems for us. Every object that we create plays a role in this solution. How do they contribute? Objects receive messages. That message can come with input or without input, and that object can choose whether that message is okay or not. When the message is okay, it can execute behavior, and when the message is not okay, the object can respond with an error. If the object will respond with behavior, then that can mean that the object itself will change or that it will return a meaningful response. So in this context, again, rules will make explicit what the system will accept, what kind of messages are okay, and behavior means how will the system respond to these messages. As mentioned before, the domain-driven design patterns help us to implement this construct while we're coding. Here's an overview of some of the common patterns that you're probably quite familiar with. Identity, state, rules, behavior. Only entities have identity. Only entities are mutable. The other objects are not mutable. In fact, services don't even have state. They do have collaborators, but that's called aggregation, and I don't want to use that word in this presentation. All kinds of objects can implement rules. Can all kinds of objects implement behavior? Can value objects implement behavior? What do you think? After my previous session, there was some question. Do value objects just implement rules, or do they actually support behavior? Well, take a look at these examples. Here are some simple value objects that receive messages and respond to them. Because value objects are immutable, they will always have to respond with a new version. It can be another return value, or they can respond with a new version, a different version of themselves. That makes all methods that you send to value objects query methods. So, can and should value objects have behavior? Yes, I think they can. In fact, let me answer it with a meme. If you say value objects don't have behavior, then I say, haha, value object go brr. They don't just make the incorrect inexpressible, they make the correct very expressible. Value objects, just like any other objects, solve problems for us. So use them to solve those problems. So let's take a look at one of these message passes that we saw. Here we have an object today, and it receives a message previous day. How should the object respond to this message? Is there anything that can go wrong with this message? There's very little input. So is there anything that can go wrong? Well, maybe. Maybe given the current state, the object doesn't support this message. But if you envision the domain a little bit, then yes, today can probably tell you what yesterday was. This value object could be very useful. How would the object know if the message makes sense? Well, it looks at the message. There is no input, so there is very little to decide on whether this message is okay or not. Can we make it a little bit more complex? Sure. What if we pass a message with an input? Here we have today, we ask for it a different version with day 32. Now that can mean several things. It could mean with day of the year, day of the week, day of the month, but let's assume it's day of the month. Then this message is a little bit weird. The object should probably reject this message because there is no month that has 32 days. How would the object know? Well, just from the message itself. The object knows enough just from the message input that it should reject it. How about this one? Well, this one is quite obviously not right. This message is quite obviously not something that the value object could work with. So tactical patterns and value objects specifically make the incorrect inexpressible. So what if the questions become a little bit more complex? What if the object cannot tell from just the message? Here, for example, take a look at this balance object. This balance object is something that holds a certain amount of money, and there is a rule that the balance should always be at least 0. Can we tell, just from looking at this line of code, that this message makes sense? Well, not really, because this message could make sense if the balance is large enough. But if the balance is too small, then the object should probably reject this message. So the object needs not just the message itself, but also its current state to determine if this message makes sense. Still, it has that state, so the object knows enough to answer this question. One more example. Here we have a meeting service, and the meeting service gets a message that says, "Get current meetings." How should the object respond? Think about this one for a second. How should the meeting service respond to get current meetings? Well, if you paid attention at my previous talk, then you're going, oh, it depends. Yes, I won't try and trick you again. It was lame the last time. It will be even lamer if I did it this time. So let's look at what these words could mean. Current meetings. So current, something along the line of active, a specific set of meetings that adheres to a certain specification, and meetings probably some kind of entity that will come from a database or some other source. So this meeting service would use a collaborator or two to gather information and then make a meaningful response to this message. This message in and of itself is really simple. It doesn't have input, but the service needs a lot of information to be able to respond to it. Too much information for an object to hold in memory. Let's extract a model from some of these examples. Here we have a model about information size. On the left side, objects use only the input from messages. In the center, local state, and on the right, access to the global state. Where on this line would you place value objects, entities, and services? Value objects would probably mostly tackle problems that require not too much information and that can be answered to a large degree by the messages that the object gets sent. Entities have more information available to them, can answer bigger questions, can satisfy bigger rules, can exert bigger behavior. Services have no state of their own, but through collaborators have access to the global state. And that makes services able to answer to any question. So where would we place aggregates here? What if we have a need for information because we have a rule or a certain behavior that requires multiple entities, but few enough that it could still sensibly fit in memory? Aggregates would go somewhere around here. Aggregates can satisfy cross-object decisions, usually. Let's take a look at what that would look like. Here we have an aggregate. I drew a boundary around the aggregate. The aggregate consists of several objects grouped together. All these objects have consistency, rules, and behavior shared. There is truth inside this aggregate, and the aggregate makes sure that it remains truth. The only part of this aggregate that is exposed to the outside world is the meeting. The meeting is the so-called root entity. The outside world can only access this meeting because the meeting and the rest of the aggregate together have to make sure that it stays consistent. The meeting doesn't have to do everything on its own. It can still delegate to all the other entities and objects in the aggregate. These entities are problem solvers. And even if they have multiple value objects behind that, they're all problem solvers. And all these objects play a meaningful role when satisfying these rules and behavior. So the root entity shouldn't do everything itself, but it should at least delegate, and it's responsible for maintaining the consistency of this aggregate. A service that would use this aggregate could look something like this. The service is responsible for loading the aggregate from a repository. It then dispatches the work to the aggregate. It makes sure that it catches it if anything goes wrong or not. And then it saves the aggregate back into the database. The aggregate does the actual work. Now, this saving goes in a single transaction. Aggregates are saved and loaded in single chunks. That's called transactional consistency. Aggregates make sure that whenever a part of it changes, the whole aggregate changes. It's all or nothing. There's some rules for working with aggregates. First off, no mutable objects go in the aggregate. The aggregate is responsible for creating its internals. If we were able to pass objects in that would be mutable, then we could change the aggregate from outside in after the fact. That's not something the aggregate should support. So if we want to do something with an aggregate, say add a new entity to it, then we give the aggregate the message to do it for us. Tell, don't ask. We also are not able to get objects from the aggregate. The aggregate only allows values to go out, no entities, no mutable objects. Now there's a couple of ways that you could deal with this. I don't really want to get into CQRS. It's a complex topic and it's explained by people much smarter than I am. So I don't even want to touch it right now. I myself prefer, if I don't do CQRS, to have the right model give a view version of itself that you can actually ask questions. This still allows you to have a right model that you can work with and a view model that you can inspect, but you can't inspect the right model. No objects leave the aggregate, only values. And thirdly, kind of makes sense, but updates to the aggregate always go through the root. There is no way to get a reference to an object inside the aggregate. The root is the only source that you have to talk to the aggregate, the only place that you can send messages to. Why? Well, the root is the responsible object for guarding the consistency of the aggregate. So anytime that the aggregate is touched, is changed, gets a message sent, then rules need to be performed. The root has to make sure that those rules can be performed. That's why the root is the only part of the aggregate that you can talk to. So only the root is exposed. The rest of the aggregate hides behind the root. Only values go in and out. Entities do not cross aggregate boundaries. Let me repeat that because it's important. Entities don't cross aggregate boundaries. So aggregates are a tool that will help us perform rules and behavior over chunks of information, over groups of objects that are too big for a single entity, too small for a service, or small enough that we don't need a service. That sounds pretty nice. This gives us a lot of advantages. We'll talk more on that later. So why don't we aggregate all the things? Why not make everything one big aggregate or make a bunch of big aggregates? Anyone else work with Galera? Because aggregates tend to become somewhat bigger, persistence is complex. Storing aggregates, getting them back can be complex, depending also on what any particular framework or ORM will provide for you. Storing these aggregates can be a challenge. At my work, we don't use an ORM, we just write plain SQL. So that gives us some advantages of storing complex object graphs. It gives us some disadvantages on storing simple object graphs. Because persistence is complex, you can run into problems with locking. I don't really want to talk too much about locking today because it's a complex subject that deserves almost an entire session on its own. But locking can also be hard, provide some challenges, especially if you have concurrency, which I really don't want to get into today. Also, the performance of aggregates tends to get worse as they grow. That doesn't have to mean grow in terms of how many different kinds of objects are in the aggregate, but it can perfectly fine be how many of the same kind of object are in there. So if you choose an aggregate, like for example, the meeting with the registration that we saw, if we choose that solution for meetings that can have hundreds or even thousands of registrations, that probably will stop performing quite quickly. So aggregates have some big upsides, have some big downsides. We'll talk more on that later. For now, value objects help entities be consistent. Entities can be part of a root, part of an aggregate or the root of the aggregate. Aggregates offer us transactional consistency. And services, if you implement it, offer us eventual consistency. The need for information is what drives design. At school, I learned first you create a database diagram, you create a class model, and at some point you're going to integrate them, and then you're going to cry. Because rules and behavior is what need information. So the objects that need to solve these rules and behavior, those need the information, not because I came up with it in a database model, but because I need those objects to do what I need them to do. So objects, give them what they need, give them the information that they need, and let what they do for you guide where the information in your application goes. Object behavior is what we want to drive our design, not in availability of information. So to summarize this part, objects solve problems for us. We split those problems into rules and behavior. Rules and behavior need information to be satisfied. That information can come from identity, from state, from collaborators. Value objects have no identity. Entities have everything. Aggregates group objects that are affected by rules and behavior behind a transactionally consistent boundary. Services group objects that are affected by rules and behavior behind an eventually consistent boundary. So, now that you know what an aggregate is, should you use it? Well, let me repeat again at this point. The pattern that you use to solve your problems is a choice. It's a design choice. So let's evaluate what we can do with this choice. Let's talk about context. Functions can have two kinds of input and two kinds of output, implicit and explicit. We already touched on this a little bit in the previous section. But every function that we call, we can give it input in its function arguments. When we send a message, we can give that message a payload. But the function, while executing, can also get information from other places, from local and global state. The function can give us a return value, or it can, as a side effect, update local state, or even call functions to other collaborators that will do things like query databases. So let's look at a little example. Here is the current meetings function that we saw earlier. This current meetings function has no input. It does have two collaborators. So it combines this context that it got from the collaborator with this context that it got from the collaborator with this context that it got from the collaborator. and then gives us a response. How do we test something like this? Well, it could look something like this unit test right here. This looks quite doable. We have some hard-coded context. We instantiate a meeting service with an in-memory repository, a dummy version of that collaborator, and we instantiate a clock with a hard set date instead of a dynamic clock. We then plan a couple of meetings around that concept of current, and then expect that what we get out of this function will actually match what we expected. This looks very much like a proper unit test. This doesn't scare me so much. How about this example? This is a little bit more complex. Registering for a meeting. Here we have our registration service, and we call the function register attendee. We send the message register attendee with a couple of IDs, a meeting ID, an attendee ID. This gets quite complex. So here we have input. This input is then used to gather this context, make sure that the meeting and the attendee actually exist in the system. Then there's this context to make sure, is the attendee not previously registered? Then we can actually do some work involving the entity of meeting, the aggregate of meeting, and then we can save the results as a side effect. How would you test something like this? Well, if you're smarter than me, then you'll probably have some very nice feedback. I usually don't really know how to make it better than involving mocks. Involving mocks or in-memory variants, but... So, is there a better way than doing this? Can we perhaps do integration or database tests? Just test the actual real-world code? Well, we could, but that would be a performance problem, and we want to execute our unit tests quite quickly. So I guess we have to resort to mocks. Oh, oops. I really don't like mocks. That doesn't mean I don't use them. Earlier this year, I created this one. This is copy-paste from my own code from earlier this year. I didn't change a single character. This is code that Pim writes. It's real code. Now, to be a little bit fair towards myself, this was a test for legacy code. We were refactoring the legacy code. It had no tests. So we were adding tests like this as a kind of scaffolding so that we could start changing code knowing that we didn't break anything. But this stuff is very, very brittle. Very coupled against the implementation. It did have 100% code coverage. Yes! Now, I don't know about you, but mock and spy make me cry. I want to test complex logic. I don't want to write complex tests. So why do these tests become so complex? Let's see. So this is the example we saw before. This is a diagram of how these function calls go. We have a handler that calls our service. This service then asserts that the meeting exists by calling the repository. It asserts that the attendee exists by calling the repository. It then asserts that the attendee was not already registered by calling the repository. And if all those conditions are satisfied, then the registration service will actually register the attendee with the meeting. So this service coordinates this interaction. The repositories pull in all the needed context. The service then makes a decision on what to do. The meeting, which is a very small aggregate in this instance, doesn't really do anything. It just gives the final push, you could say. It's a bit anemic, but it's loosely coupled. The incorrect is inexpressible. But for unit testing, it's non-plus ideal. It means we have to write mocks or do something smarter that you're all ranting at me in the comments about now. It's a downside to online No idea how angry you are with me already. So for testing purposes, this is what we would call white box testing. We have to know the internals of this service in order to write tests for it. We have to know how to respond to the messages that will be sent. In fact, we have to know which messages are going to be sent. The context is implicit and ad hoc. It means that we pull the context in as necessary. This function is hard to test. How can aggregates help us here? Let's look. Here is the same behavior, but then implemented with meeting as a slightly larger aggregate. In fact, meeting as an aggregate now encompasses registrations. So, similar to before, the service coordinates. It makes sure the meeting exists, it makes sure the attendee actually exists, and then it just passes off the work to the meeting, which of course internally still does the work, and then returns either a success or not. And then the meeting, the aggregate as a whole, gets saved in the repository. So what the service really does here, it still coordinates, but it doesn't do any work itself. It just loads the context and then passes it on. So how does this affect our testing? Well, we still have a white box test for the meeting service, but we now have a black box test for the meeting itself. So all the business logic is covered in a way that we don't need to write mocks for. We don't have to know how this meeting behaves on the inside because the context is explicit and prepared. So all we have to do is test the input and the output of meeting, and we can write perfect unit tests. No need for any mocking, no need for any dummies, no need for any integration testing. But when we talked about the downsides of aggregates, one of the things that we mentioned is that aggregates might become too large. So let's say that this meeting could not contain all those registrations. Then we can't do this little trick that we did right here to make this test simpler. What can we do? Well, as with everything in domain-driven design, as much as I like to come up with my own slogans, the best domain-driven design slogan is still make the implicit explicit. So let's go back to the first version and then make that context explicit. That could look something like this. Now this one is a little bit more complex, so let's go through this quite slowly. Again, like in the previous examples, the service coordinates the interaction between all the involved objects. The service calls on all the repositories to load their context. There is a meeting repository that still loads the meeting. The attendee repository still loads the attendee. And now we have a registration repository that instead of doing a check for us, gives us a list of registrations for this meeting. Infeasible if this is 1 million registrations, but quite feasible if this is a low amount. This list of registrations object can do some work for us later. Given this meeting and this list of registrations, we instantiate a use case or context object. It doesn't really matter how to name it. If you ask James Coplian, he will call it a context. If you ask other people in Ruby, they would call it a use case. It doesn't really matter as long as you give it the context prepared that it needs to do its work. This object will be responsible for having this interaction work as it should be. Now this object is pure-ish, side effect free, so it will do its work as it's called, return a normal result, and give us an interesting effect on testing. The test would look something like this. We still have the white box for meeting service, but we have a black box for context. This context object, we don't need to know how it behaves on the inside because everything is explicit. It doesn't do any calls to the outside world. It doesn't do any weird updates. All it does is it receives a message and it responds to that message. So this context is very explicit, very prepared. That makes it easy to test. It makes it easy to write a test code for. We test the input and the output of business logic. The aggregates here involved are also small. So this is, in my opinion, for complex cases, the best of both worlds. So implementing this would look something like such. Here is the registration service code, quite similar to what we saw before, but instead of directly calling rules and behavior itself, all the registration does is shape the context that we're going to execute that context, and then saving the result. Now think for a second. What did I move to register new attendee to the context class? Or another way to ask somewhat of the same question, what reasons are there for this service to fail? What reasons are there for this context to fail? So what reasons are there for a cert meeting exists to fail? Well, there's a couple of race conditions that could happen, but mostly it will be something along the lines of a programmer error. This function should not have been called with this meeting ID. The same thing goes for attendee. All kinds of race conditions, sure, but likely it's just a bad function call. So this service deals with programmer mistakes, hackers. Now this context, given that these objects exist, given that these objects can play a role, this context deals with actual business logic. So it's user world. The context would look something like this. It's a pure-ish object. It's explicit context. It has no side effects that it calls, super easy to unit test. Now, it is extra work. We have to create the use case. You have to create this list of registrations. So this is not something you would use for every feature. This is something that you would use every now and then. So how would you decide when to use it? Well, I have no clear-cut answer for you, but I have a heuristic for you that we like to use at work ourselves. And the heuristic is called one, too many. If you're writing the same or similar mocks more than twice, then you could do it like this. So instead of having code copied and pasted or having even worse things happen. See, what's interesting, when code has many reasons to fail, like the previous example that had at least 4 reasons to fail, when code has many reasons to fail and even a couple of reasons to succeed, that means we have to create many tests. Many tests, especially if you have to do a lot of mocking, will create programmer frustration. When programmers get frustrated, they start to be creative. They start to automate the test automation, and then your tests become more complex and more complex. And all of this to hide the complexity that is inherent in the domain. And that's really interesting. Domain-driven design is about tackling complexity in the heart of the domain. So whenever you find something that is complex, make it explicit. When you find something that's complex, make the complexity explicit. If you can use an aggregate, that's perfect. If you, for technical reasons, can't use an aggregate, then there are other ways. So, my view on implementing rules and behaviors in either services, aggregates, or context objects. If you are looking for performance, then you're not going to use a big aggregate, because big aggregates are just not that performant. So you're probably going to fall back to a service. If you have trouble convincing your coworkers that the code overhead is worth it, you're probably not going to convince them of the context objects. If you're worried about complexity in your infrastructure, in your persistence, aggregates might also be a drawback. If you want to have unit tests, for example, because your code is getting complex, I highly, highly, highly recommend using context objects. So services provide you eventual consistency, aggregates provide you transactional consistency. Service plus context, it depends on whether you use an aggregate or a service or just what you prefer. So in conclusion, I would use aggregates for when you really, really, really need that transactional consistency. I would use services as you're probably already used to most of the time. But for those complex cases, make the complexity explicit. So To summarize these past two chapters, objects receive messages. The information that is needed to respond can come from the message to the local state or the global state. The more information is needed to respond, the more difficult it will be to remain transactionally consistent. The domain-driven design technical patterns help to make the incorrect inexpressible. Value objects and entities are relatively well understood tools, but there still are misconceptions. Value objects can have behavior. Aggregates are a tool to maintain transactional consistency and chunking. Services are a tool to maintain eventual consistency. But services, and especially when they have many collaborators, tend to be not fun to unit test. So when you do want to unit test them, use context objects to facilitate localizing information while still maintaining eventual consistency. Context objects help to separate technical concerns from business concerns. Context objects help to make the complicity explicit. That was the hard part. We can all relax and breathe because everything that was challenging and technical is behind us. I hope you don't have too many questions after this. I hope it was somewhat clear. All that remains for us now is just a couple of heuristics to ponder, to just get in the back of our heads or something. So heuristics are anything that provides about a yada yada. Heuristics are guidelines, more guidelines than actual rules. They can be useful. They can help us to not think. And if there's anything I like, it's not thinking. But be mindful. They might not always be true. So everything is a value object until it's not. We really do prefer to put everything in value objects because value objects are simple to test, simple to understand. Aggregates guard transactional consistency, services guard eventual consistency. This one's not entirely true. Aggregates do guard transactional consistency. Services, depending on your implementation, do not or do guard eventual consistency. You still have to implement it yourself. And if you really have a good business case for consistency, then use aggregates. But programmers make rules that are often only theoretical. Programmers really are, in my limited experience, my own, not very good at choosing aggregates. So if there is a rule that a programmer says, yes, but we have to, unless business people say we have to, then perhaps it shouldn't be an aggregate. And even if the business people say it, still doubt it. Value object before entity, before aggregate, before service. Keep your aggregates small. This one is, very sensible. If aggregates become too big, they will become a performance bottleneck. Persistence will become complex depending on your storage mechanism. Keep your aggregates small. Push context and side effects to the edge of the domain. This one really is very sensible. The more of your code can run without worrying about context and side effects, the easier it will be to write pure unit tests for it. Push context and side effects to the edge of the domain. And finally, of course, rules and behavior at the information. The need for information is what drives our design. Rules and behavior at the information. Thank you very much. That was it. Only one question for us to ponder on. Why do you think there is so much confusion about aggregates? Maybe this would be interesting for later. That was it. Thank you.
And we had lots of questions. We have real huge discussions happening in the chat.
So let's be fast. Should we pass the aggregate around, for example, to convert it to HTML with Twig or to convert it with JSON?
Nope. Aggregates, entities don't cross aggregate boundaries. Aggregates don't cross service boundaries.
Okay. So having a core domain shared between different microservices, should we do it or not?
Nope.
Okay, I expected this, okay.
Okay, how do you recommend to define context boundaries?
Define context boundaries. Gee,
Yeah.
ask a simple question. Next.
Okay, if you think it's too long to answer, we can move it.
Yeah.
Okay.
It's a really good question.
The registration service is an application or domain service, and what is the difference between them?
An application service doesn't contain business logic. So the moment a service starts containing business logic, if it's part of making the incorrect inexpressible, then it has to be a domain service. So sometimes you'll see people using command handlers already as a domain service. That's tricky, but I also respect that you don't want to have like a command handler as an application service and then a domain service that does nothing except pass on everything that needs to happen. So I get it. If you want to be very proper, then the registration service would be part of the domain and the handler would be part of the application.
Okay, we have to choose another one. Should we always test the main model without a real persistence layer?
Yes, of course. See, the point of the domain layer is that it makes interesting decisions. So you want to be able to test those decisions. This is the slide here. This one. So what we do is you have a couple of tests, integration tests, just a few to verify that your persistence mechanism is working. Perhaps there's some weird edge cases that you also have to test, but the bulk of your tests will be unit tests that verify that your domain makes the incorrect inexpressible.
Okay, and the next question is register new attendee class body may be actually a part of aggregate itself? Why should we move this logic out of it?
Because the information that is needed is bigger than the aggregate itself. You could pass it as a collaborator to the aggregate. That would be fine too, I guess. But I like to make it explicit as a complex case. So if it starts growing, then your aggregate will also start growing. So experiment with it. I think it's a good suggestion, but I can't include everything into one talk. So yeah, but good suggestion.
Okay, thank you very much for your talk, and we hope to meet you at 17:50 at the Q&A session. And for everyone else, thank you for asking really good questions. It's really a great pleasure for all speakers to have an active audience. Yeah, thank you.